Hello everybody, today we talk about the WATERAGRI Project, which has been funded by the European Union's Horizon 2020 Research and Innovation Programme. The WATERAGRI vision is to solve agricultural water management and soil fertilization challenges in a sustainable manner to secure affordable food production in Europe for the 21st century. On this slide, you can see our virtual kickoff meeting pictures. Our WATERAGRI objectives are to co-develop the links between agricultural land and soil sediment water management, to undertake technical and sustainable assessments of proposed measures, to develop a cloud-based simulation and data assimilation system, to identify, develop and test affordable and easy to implement technical and operational farm solutions, to assess the proposed techniques for their potential regarding adaptation to climate change, and to disseminate the implemented innovation to farmers, advisory services, and decision makers. On this slide, you can see our WATERAGRI pilot sites. In Finland, there are two. In Sweden, there is one down in the southern Skåne. In Germany, there is one site near Aachen. Then we have one site in central France and one in Poland. We have a plot in Zeeland, in Switzerland, and one near Vienna in Austria, one in Hungary, and last but not least, a plot near Milano in Italy. So, what do we expect from these pilots? With respect to our first Finnish sites, improvement of water regulation for potato farming and the development of automatic drainage. In Finland, the second site, water regulation to limit subsistence, nutrient and acidity leaching, and greenhouse gas emissions from organic soils. In Sweden, to improve the planting sequence and field management. In France, adjusting crop rotation, nutrient management, controlled drainage, and wetland technology. And in Germany, determination of drought stress responses of plants to optimize irrigation. With respect to these pilots, you can see pictures associated with the individual pilot sites on these slides. In Finland, we look at potato farming on mineral soils in regionally and European-wide important area of farming. In Sweden, we have 200 hectares of organic and 800 hectares of conventional farming. In Germany, we have crops such as sugar beet, winter wheat, winter barley, maize, and rapeseed. In the second site in Finland, we have grass production on shallow peat soils overlaid by problematic acidic sulfate soil. In France, we have 4,000 hectares of water catchment area planted with soil, seed, rape, wheat, barley, and maize. What do we expect from our pilots? In Poland, improvement of water availability resulting in high yields of cultivated crops. In Switzerland, maintaining the high level of food production through intelligent water, soil, and nutrient management. In Austria, investigation of water flows on the farm level for improvement of irrigation of different crops. And in Hungary, a reduction of artificial fertilizers to adapt to climate change and a reduction of available conventional water resources. And finally, Italy, optimization of irrigation water retention, agriculture drainage, water treatment, and nutrient recovery. On these slides, we see the corresponding pictures to these pilots. In Poland, we're looking at wheat, rye, maize, barley, oat, and oilseed rape. In Austria, we have an experimental agriculture field. In Italy, we have different crops, winter wheat, soya, maize, fruits, vegetables, and so on an agricultural farm. And in Switzerland, we undertake vegetable farming. And in Hungary, we have 16 hectares of pasture with sprinkler irrigation for cattle grazing and also 50-hectare irrigated arable land. So on this slide, you can see some of our WATERAGRI solutions. In the center, we have the modeling framework. So we have first as a solution the framework itself, then the integrated physically based terrestrial system models, the decision support system. We have on the right-hand side water vapor absorption, isotherm, and water retention characteristics model. We have WebGIS for zoning landscape matrix, and we have the series gaming. The next slide is also about WATERAGRI Solutions. Innovative and sustainable water retention solutions are listed here. We have on the left-hand side the farm-constructed wetlands for water retention, remote sensing pipeline, irrigation management and agrometeorological monitoring solutions, and precision irrigation system. And on the right-hand side, enhanced water retainer product and concept, the biochar for water retention, tracer methods, and dewaterablity estimation test apparatus. On this slide, you see the WATERAGRI Solutions in terms of nutrient recovery. There we have the farm-constructed wetlands for nutrient recovery, we have the drainage systems, we have bio-based nutrient collecting membranes, we have biochar absorbents for nutrients uptake, and we have microfluidics. So now to our WATERAGRI innovation potential. We have the framework in combination with modeling. The developed framework will support near real-time decisions for the management of small agricultural catchments. We have the serious game. The goal is here to engage the farming community and increase acceptance of the proposed solutions. And we have the wetlands. WATERAGRI will use monitoring technology to expand stakeholder knowledge, reduce uncertainties of nutrients and water retention processes in the field and catchment. On this slide, there are more WATERAGRI innovation potentials with further technologies. First, the remote sensing pipeline. WATERAGRI will utilize recently developed remote sensing techniques together with various satellite images. Dewaterablity estimation test. We will develop the DET to test how easy it is to dewater mixtures of soils and liquids such as agricultural wastewater. And finally, drainage systems. WATERAGRI proposes a multifunctional bio-inspired drainage system that will help to reduce irrigation water use and to enhance nutrient retention capacity and plant uptake. On the next slide, further innovation potentials associated with our solutions. There's a nutrient recovery by membranes. It provides a new option to reduce the eutrophication impact from agriculture and improve nutrient self-sufficiency. Then we have biochar. Biochar will improve the moisture retention capacity of soils and act as nutrient absorbent from the runoff water. And finally, we have microfluidics. We will enable the agricultural community to benefit from this energy-saving and compact technology. So, finally, a quote from myself. The WATERAGRI project is about researching the new frontiers in integrated water resources management of small agricultural catchments to improve both European agricultural production and the status of local ecosystems. On this slide, you can see our 23 members. There we have Lund University, we have Eden Microfluidics, we have the Forschungszentrum Jülich, we have VTT in Finland, and we have our friends from Hungary. We have Alchemia Nova from Austria, we have Agrogeo, then we have Bocco from Austria, then we have our friends from Italy, Bologna University, Salford University, and also Canal Authority in Italy. We have CDR from Poland, Innocence from Serbia, we have Waschlos University by Zoltan, we have Vultus in Sweden, and we have TU Delft in the Netherlands. We have Unine in Switzerland. We have our large farm, Gårdstange Nygard, in the south of Sweden. We have University of Oulu, Agricolus from Italy, Indra E from France, and finally Regelsberger from Austria. You can follow us on our website, or you can have a look at social media on Facebook, on Instagram, and on Twitter, for example. So, thank you very much for listening. If you have any further questions, you can contact me on miklas.scholz@tvl.lth.se or just phone Sweden 0046 and then the number 703435 270. Thank you again for listening.